I'm Caden,
I'm Xavier.
and this is our project. I do apologize, I'm a bit under the weather, so you will hear some coughing in the background. So, for our project, we are planning to do a Tetrio Wrapped, which is like Spotify Wrapped, but for Tetrio. Tetrio is essentially a online video game of competitive Tetris, where you play Tetris against other players. With a very, its main focus is on a versus mode, and it also has a very extensive API. So essentially, what we decided to do, is to utilize the Tetrio API to give a user a recap of their skills, and then we also used it to compare a user to other players of its rank and calculate an archetype of that player. So, without further ado, we will be showing you the UI for this app. So basically, how our system works is that you put down your player. So let's take Kaboozle Pi, one of the greats of Tetrio, and we'll fetch the data from the API. Afterwards, you see all of his data out here. You will be able to compare him against other ranks. So, for example, if you compare against the top echelon of Tetrio players, he still does very good because he's a top player among the top. And afterwards, filling out this rank comparison will also automatically fill out this archetype. And we will calculate an archetype for Kaboozle Pi. We find him to be an opener main because of a system that we'll describe later. Note that this also works for other players as well. And if you compare me, for example, against the top of the top, you can see I'm very deficient. But against my peers, we can calculate our own archetype, and we find we're just a solid player. The way we utilize this is through lambda functions to do a lot of our calculations. So one of the first lambda functions we call is get Tetrio game history. So what essentially it does is that it pings the Tetrio client or Tetrio API with with your username in order to get some statistics such as attacks per minute, pieces per second, etc. And after we use that with our name, then we go and we calculate some of our own statistics instead of called total garbage sent, total garbage received, etc. in order to inform our model. Afterwards, we send this back to the client, which will then, once you click the run comparison button, it will send information to this lambda function, which essentially compares your stats to the average stats of those in a rank. To store these average stats, we actually have a database out here called Rank Breakdown, which stores the rank names and a couple of their stats. For example, an SS rank would an average SS ranked player would put down 1.95 pieces per second, while an average X player would have an attack per minute of 131, etc. And we use those stats to the UI will and client will ping this lambda function to which will go to our RDS database and get these stats and send it back. Afterwards, the UI will use both your stats and the average stats of those in a rank to calculate your archetype.
All right, and this is where the main theme of the Tetra wrap comes in, where we have essentially come up with a few archetypes that can describe different kinds of players. For example, we have the average one, opener main, sprinter, etc. And these archetypes depend on the percent difference from the average for a given rank. So you essentially, this function will take in a set of relative values, relative statistics, and that will be based on percent difference from the average for the same values for that player's rank. And then once that happens, we compare the input user data to the sort of statistics that have been manually set for all of these archetypes through this archetype class. And each one of these archetypes will compare itself to the given data using a little function here that will sort of calculate a similarity score. And whichever archetype is the closest to the input user data will be returned as the name as well as the percent similarity to that archetype, as you saw in the UI. And then our client-side functions are three functions here that reflect the Lambda functions that are accessible through our API. So get aggregated user stats is the client-side version of the first one, which just returns the total statistics for a given user. Um, we have get rank data, which of course just returns the same data for a given rank. Um, and then get user archetype, which is what I just talked about, returns the archetype and the similarity given all of these inputs. So they pretty much directly just call the lambda function and return the same result.
Yep. And we use these client-side functions in order to inform our UI with a couple of statistics out here. And one of the things we do calculate in our UI, which if we had more time, we'd figure out a way to offload into a Lambda function, is we found the relative comparison to the stats. So for example, if you have 100 APM and your peers have 50 APM, this will calculate you being around 200% of an APM of your peers or 100% better. So that's how we do it in here. And we use Streamlit in order to, as basically our front end in order to display everything here. Um, we will mention that we did use AI to generate the UI. However, due to the precedent set in Project 1, Section 3, um, we found this to be acceptable with the parameters of our AI integrity. We reused a lot of code from Project 1 and 2, but we did not use AI for the backend or any of the Lambda functions. So this is our
Yeah,
project. Thank you for listening.
thank you.
Bye.